Okay, everyone, very welcome to Jfokus Brown Bag Lunch on February 23rd. And today we have Andrew Harmel-Law from Scotland, right, from ThoughtWorks, who will tell us about domain-driven design. And he will be speaking for about 50 minutes. And we will let you all leave in time for the 1 o'clock meetings that some of you have. But if you want to stay on for some more Q&As after, that's fine as well. I would like to introduce some of the Jfokus people that are here today. It's Mattias Karlsson, who's the big boss. And then we have Niklas Finne and Enno Rönne. And I think maybe we have Joachim here somewhere, or maybe he will show up. And we have a new member actually of the hosting team today, Lucy, because he was let in very early in the meeting. So we're going to bring you in. If you come early, you have to help out next time. All right. So Andrew, do you want to introduce yourself first and then share your screen, or you want to just start sharing your screen?
Yeah, I'll start sharing my screen because otherwise.
Yes, go ahead.
So yeah, hello everybody. Thanks for coming. So like Elena says, I'm going to make sure I go fast so I can leave space for questions. There's a few gaps that I've got because hopefully the structure is quite clear, and so therefore we'll go on a bit of a journey. I'll talk a little bit about the structure in a second, but if you've got questions during the thing, I won't be able to see chat because I'm trying to read my notes. So, but Elena is going to look at the chat, and so therefore if there is anything, we'll have pauses where we can kind of catch up and make sure. So if you've got any questions, please put them in chat. And also, I don't have a lunchtime meeting, so I will be around if people want to ask questions. And my Twitter handle is at the bottom as well, which is not very obvious, but it's my login from when I worked at Sun Microsystems. So if you want to ask me a question afterwards or whatever, or follow me on Twitter, then that's cool. You can use that too. So I'm going to talk about the heart of domain-driven design. I'm not going to talk about the microservices bit. That's an extra half hour at the end. But there's complete speaker notes on everything, and I'll share the slide deck afterwards. So if you want to read about that, you can look at that and A, maybe see what I've said, but B, catch up on the extra bits. So if I start my timer. So yeah, quick little bit about me. I'm a consultant. I work at ThoughtWorks at the moment, and I've been here for 3 years, but I've been a consultant for 15 years. I've worked across different sectors, public and private, and I've been doing domain-driven design for 12 years, and it's been making my life personally better ever since. These days, I'm trying to do more speaking about DDD so that more people can kind of understand it and use it and to make their lives better. And in the last 6 months, luckily, when we got put on lockdown in the UK, O'Reilly asked me if I could write a training course. So I've got a 3-hour domain-driven design first steps course, which covers lots of the things we're going to cover here, but it's hands-on, so you get to write code. And the next one is next Thursday, if you want to sign up to that. So what I'm going to talk about today is what I think is the heart of domain-driven design. So everything I'm going to talk about is in this book. The book is Domain-Driven Design by Eric Evans, that came out in 2003. There are loads of other books in domain-driven design, good books as well. There's lots of pamphlets, training courses. There's not just my training course, there's lots of other ones. There's Git repositories like the DDD crew have some cool stuff. There's meetups, conferences, etc. There's loads of things around DDD. But what I want to talk about is in this book, and specifically how we can use what's in this book to tackle the subtitle of the book. So that subtitle is Tackling the Complexity in the Heart of Software. So firstly, what's the heart of software? On page 4, Eric makes it clear. So the heart of software is its abilities to solve problems for its user. All other features support this basic purpose. And unfortunately, and I include myself in this, I don't think we're always brilliant at this in software development. The second question is, where's the complexity? So this is in the foreword by Martin Fowler. It doesn't even, you don't even have to wait till the book itself starts. And he says the complexity is the essential intricacy of the problem domain itself. So it's the complexity in the heart of the business problems. It's the complexity that our users have to deal with. So it's not the complexities in the software. It's not the complexities in the technology. But unfortunately, I think sometimes so I include myself, developers, architects, technologists in general, get excited by the technical complexity and we forget about the user complexity. But it doesn't have to be like this. And the Blue Book gives us really, really nice tools to tackle this and also make it fun, challenging, engaging, and just a really kind of satisfying way to do our jobs. but there's a problem. The problem is that the book is thick. I've also discovered, because I've been doing some reading groups around about DDD, if English is not your first language, which is for most of the people in the world, then it's written in quite a difficult way of writing English. So it's not easy to pick up and just consume. And I think that's one of the reasons why we don't see DDD more widely done. And therefore, we're kind of missing an opportunity to tackle some of this complexity in the user land. But it doesn't need to be like this. So that's kind of why I'm doing all of these things. So I've done talks about DDD that were small, about small things. I've done talks about DDD at scale. I've talked about how I've succeeded with DDD, but then more recently, I've talked about how I failed with DDD. And consistently across all of these talks and all of the book clubs I've run and all of the things I've done with my customers are three key concepts. And I've realized that they form a steady core. And this core is something which the entire rest of DDD rests. It's a core that I've come back to over and over again in many different domains and solve many different user problems. And I believe that if you bear this core in mind and keep it in mind, whatever you do with DDD, whatever flavor of DDD you're doing, then you'll succeed. So what are the three concepts? Well, the first one is famous. So famous it's got a chapter all to itself in the book, right at the very beginning, in its ubiquitous language. The second one is core enough to have a pattern all of its own in the book, and that's hands-on modelers. And the third one doesn't have a chapter and it doesn't have a pattern, but it's everywhere spread throughout the book. And that is multiple models. So what I'm going to do is, that's the kind of introduction to the talk. So hopefully that's give you an idea of the structure. What I'm going to do is pass through these three concepts twice. So the first time I'm going to pass through them, I'm going to define what they are from the blue book. So kind of make sure that we're all aware of the core concepts and what they mean from a blue book perspective. And then the second one, I'm going to go background and talk about the lessons I've learned, some of the complexities, some of the problems, some of the difficulties. So then, and also how they fit together. So hopefully then you'll get something useful. So you won't just learn something, but you'll get something useful. There is a third section, like I said, that's how you can take these and then build a few other DDD concepts on to get to microservices. Those aren't in this talk, but if you get these core pieces, then that should be an interesting thing that you might want to read about later on. So let's talk first about ubiquitous language. So at the start, I made it clear that DDD is here to help us solve problems in complex domains, and that's the user domains. And to do that, we need to understand this complexity, and that's the domain complexity for ourselves, so that when we design and implement the software, it'll do what the users need. So what might this domain complexity be like? So for a good chunk of 2019 and a little of 2020 until COVID-19 hit, I was in Oslo working for a banking services provider. So this isn't a picture of, obviously, downtown Oslo. This is the London Financial Services District. But what I wanted was a picture of something which kind of gives you the impression that, banking is hard, right? Banking is complicated. There's a lot going on in banking. And so the people we were working with there, the domain experts, knew about lots of these things, how banking worked. They knew about how their customers expected banking and bank accounts to work and how things should work in different countries as well. But they also knew about legal requirements, which they had to meet, and that their software had to meet for their clients, and the changes that were coming. So things like EU banking law changes, GDPR, and like I say, how banking, the laws in different countries. So I know that banks in Finland definitely don't work how people expect, or bank accounts in Finland work in a different way from how people expect Norwegian bank accounts to work. And that's the other bit they knew about too. They knew about how these differences kind of manifested in different banks, how the information flowed around, what the processes were, what the checks and balances were, how the jobs were split up and how different tasks were performed. All of these things and much, much more. All of this complexity was there in the heads of our domain experts. And that was why they were domain experts, because they built up all of this knowledge in their heads by working in the domain of banking for years and years. And they'd worked in banking, and they'd solved problems, and they'd gathered all this information over a long time. But the important thing to bear in mind is that this knowledge isn't just kind of sloshing around up in their brains in the form of raw data. What they'd done is they packaged it and packed it away nicely so they could use that knowledge effectively to get their jobs done, whether they were using technology or not. So they'd sorted it, they'd organized it, they'd focused it, And they'd constructed detailed and subtle mental models from that information. And then they'd refined these mental models by using it over and over again and applying common sense. And they had these models stored away up inside their heads. So the key to our success was to get at those models, to get at that learning. And what we need to do is not just kind of get at that learning, but get the right parts of those mental models into our software. And that would then allow us to solve in the software the problems which today we're wrestling with. So let's talk about how we might do this. How do we get at those models? So typically we get at them by communicating, right? There's no, that's not domain-driven design. That's just how we do software. And we communicate verbally and visually. And the idea is that their mental models become our mental models. They become shared mental models. And then we take those models and we put them into our software. So far, this isn't domain-driven design. I'm just talking about how we do software. So where is the DDD in this? The DDD is in the language that we use in these communications. And that language is the language of the domain and how widely we work with that language. And it's the first truly powerful concept that Eric introduces in the book. So on page 17, he says, as we talk to domain experts, we rapidly discover that their mental models go beyond find the nouns. So I don't know about in Sweden or where you might have learned about software development, but when I learned about software development in Scotland, we'd learn to do object-oriented analysis design, and we would listen for the nouns and we would draw boxes and lines, class diagrams, right? And his point is it's far more complicated. So how do we get beyond find the nouns? To help with this, what I want to do is introduce something which is a useful way of thinking about things. The first half of it is I think we should think of domain experts as developers who can't code. So here we have this domain expert, who has a very rich mental model, but they can't, code in Java or Kotlin or C# or whatever. And the second part is that we, on the other hand, can code, but we know nothing about the domain. So maybe we know something about the domain, but we're definitely not the domain expert in almost all cases. So seeing that there's an unequal distribution of skills and knowledge, and that we want to build this model of what's in the other people's heads in our software, we need to build a shared mental model. And we need to build one that's explicit and explicit everywhere. So to do this, we must collaborate and we must do this as equals. And that's why I kind of suggested this thing where we think of them as not being able to code and us as not being able to understand the domain, because then it keeps the balance. And when we use the shared knowledge, we can cultivate it all the way down, all the way to the code. And so by working like this, we acknowledge there is an unavoidable divide between domain experts and software builders. And that divide is an understanding divide, which we need to do everything we can do to close if we want to stand any chance of building software that solves real world problems for our users. But this isn't all of Ubiquitous language. There's a bit more to it. Given the importance of the communication and this mental model sharing, the last thing that we ought to do is make the divide between us and the domain experts greater. But I think everyone will recognize that we do all the time. For whatever reason and whatever, despite everyone's best efforts, this happens. So how do we do it? Well, one thing we do is, as technologists, we translate. And when we translate, we fracture the language that we're trying to use. And we're fracturing it because we don't align jargon. So jargon, I'm not sure if that translates into outside of English, but it's like the kind of the terms, the specific terms that you use in your domain. And we have a domain, it's the domain of technology. So the software development jargon that we use typically so much we forget it's jargon. So things like servers, clouds, database tables, select statements, pipelines, Scrum and Kanban, Kotlin, C#, Go, Node, microservices, etc. Right? We all know what this stuff means, but you speak to someone who's a proper domain expert, they have no idea what you're talking about. And the names of our stuff is crazy. So they think, we're taking the making jokes to them because they don't know whether we're speaking about stuff we've made up or not. So why is this a problem? The problem is we're not listening to their jargon, which is the jargon of the domain, and we're not adopting their mental models. We're taking our jargon and we're putting it on them. We're pushing those onto them and forcing them to think and talk like we do. So consequently, the jargon in our code isn't the same that they have in their head or that they want to use when they express their ideas. And so we lose insights because they haven't been able to use this language to talk to us. So maybe some people are thinking this can't possibly be true. So let's have a few examples. When a domain expert using the language of their domain says, and these may or may not have happened in real life in a banking client in Norway, they talk about crediting an account. but we hear balance plus plus, right? Or something similar. When the domain expert describes in their domain language how customers open a new bank account, we typically think insert X into accounts table, right? A new row into the table. And what we hear is what we put into the code. And so this translation is weakening communication. The subtleties and the details of the mental models are getting lost in this noise. And those subtleties and details are the things we need to solve the problems of the domain. So some people sitting here might have built a banking system, and they will know why bounces are credited and not incremented. They will know why accounts are opened and not created. But we won't know, me maybe in the past in this scenario, because I missed the opportunity to ask those questions. I didn't interrogate their language. I interpreted it as my language. So the way we solve this is that we, the technicians, align to the language of the domain. So we use the language of the domain everywhere in the mental models, in the model we put into the code. We use it in conversations, in documentation, in stories and tests, but most importantly, I'll say it again, in our code. The code needs to use the language which expresses the models, and that's the first key part of DDD. And that language is the language that comes from our domain experts and the language they use to describe their mental models. So therefore, we remove the need to translate, we unlock a path to shared understanding, and we get more accurate representation of these mental models that our experts have in their heads. So a key piece to point out is whether the language can be used in different ways. It can be in code, it can be spoken, it can be in pictures and whiteboards, it can be written, but it's still the same language, and it's the domain language we need to use. And that's how we can begin to tackle the first step of tackling the complexity at the heart of software. So first break. That's maybe the easier ones, or maybe there aren't any questions, but is there any?
No questions in the chat.
Cool.
Again, well, wait, one.
Oh,
why do you use Swedish domain language as variables?
All right, that's good. So yes, the short answer is yes. So when I built a legal system in Scotland, the Scottish legal system uses Latin phrases for certain things that happen in court cases. We translated that to English, lost half of the information, and made them translate. We ended up with Latin names for various functions and things in our code. So the same thing applies to Swedish or whatever. It should be whatever we had. There are certain types of bank accounts in Finland that I think the government provides for you. We mapped that as a type of account in our code. We didn't translate to, account type blah or something, Finnish account type or something, right? We called it because then we could talk about it with our domain experts and they would know what we're talking about. So yes, you totally should. Any more? Good. But yeah, it's a good question. Everybody asks that. It's a very good question. You shouldn't translate to English. That's just because, because Eric Evans was English, that doesn't mean that everything should be done in English. So.
But I actually have a follow-up question on that one then. And then, because I have been when teams are deciding that they need to do the domain in Swedish, they also convince themselves that they need to do the entire domain in Swedish, including the technical domain. So I don't know if you have any thoughts about that, because like you said, there are two domains.
Yeah, exactly. So this is the thing. So what you should do is up to the point where, so we're not going to cover it here, but I'd recommend people read it. There's a pattern called generic subdomain. And the discussion about generic subdomain is at some point, you shouldn't build this part because it's just something you should download or use off the shelf, right? Or it's a problem that's already been solved. And the pattern generic subdomain talks about ways to have your business domain represented in software and keep it clean and distinct, and then have the technical subdomain, which probably isn't differentiating for your business. And it's how to keep the two separate and the two clean. Because you're right, you shouldn't just go in and say, we're going to use a CMS, but we're going to wrap it with a bunch of Swedish terms to make it, not to play with our domain. So knowing where those seams lie is super important. So we won't talk about it, but if anybody wants to know, then definitely read the pattern generic subdomain.
A quickly follow-up question as well. If business is Swedish, but developers are non-Swedish.
So you could still, I think, maybe they won't know. So like we were all English. That's not true. We had a few Danes and we had a lady from Iraq, a few people from all over the place, but mainly their business language was English. But we encouraged them to talk about the concepts so they would talk about them in English, but the names of the things and the names of the processes and like opening an account and all these kind of things, they talked about in Norwegian, because that was, and therefore when they could translate it simply, they did. But when they were like, right, this is different because it's specific to us, we would keep that, and then we could interrogate that stuff. Because you don't, the point is you don't want to lose, my concept of a British bank account is probably very different from a Swedish bank account or a Norwegian bank account or whatever. So the key thing is don't lose. If you lose information, then you're going to make your life difficult. So, so hands-on modelers. Ubiquitous language is not enough. So now we're going to talk about part 2. And what we need to do is meet in the middle. That's what we're going to talk about. And that's hands-on modelers. So we left off with ubiquitous language, right? So everybody's using it. And this kind of goes to Matthias and Helena's question. So we've got ubiquitous language and it's coming from our domain experts' heads, right? And it's traveling in one direction, but one direction isn't enough. It's not enough to take the mental models from our domain experts and put them into code, or just, repeat back what they say, right? Maybe at best asking clarifying questions. We need to do more than that. And what we need to do is kind of our models need to become richer. We need to build them up and understand them. And our models include things, especially in the code. So we need to take our growing domain understanding and the models we're building, put them into code and try and solve real world problems. And when we try and solve those problems, we'll hit difficulties, right? And then we need those difficulties, because we'll have thought that we've understood the domain in the domain language. We use that to try and solve a problem. It won't work. We need to take that back and have a deeper conversation with our domain experts. And therefore, we will gain deeper understanding of the domain and the language. And then we can focus our models and sharpen them. And those are models which we are creating with everyone on the project, right? So we're not taking the raw mental model in our domain experts' heads. We're not taking the raw technical model. We're creating something in between, which is a combination of both. So we'll use that. We'll uncover complexities and ambiguities, which a quick look doesn't discover. And again, Eric talks about this. So he says, in having these conversations where we have we think we've understood things, we try and write some code and we realize it doesn't work, we come back and have this conversation. In having these conversations, you both go on a journey. So that's a domain expert and the technical software delivery person. Domain experts are usually not aware of how complex their mental processes are, or even they might have multiple mental models. They will conflict because there'll be different models for different jobs that they're trying to do. And we'll come back to that in part 3. And how do we get to this? We do this by getting hands-on, right? We don't just speak the ubiquitous language. We need to think in it, we need to crunch it, and we need to code in it. And we means everyone. It doesn't just mean, someone else. So therefore, we ensure the conversations are going both ways. And the ubiquitous language is being updated and grown between us as a result. And if we don't grow it, if someone says, well, that can't be right, I'm always right, this is... I built a system for lawyers, and lawyers sometimes think that they're always right, even when their mental models conflict. You need to build something together. And if you can't, then you'll fail. But just with ubiquitous language, there's another problem which DDD solves, and it's the problem of ownership. So traditionally in software, and I still see this, there's an over separation of analysis, design, and programming. And that's, it was a disaster in 2003 when Eric wrote the book. It was a disaster before, and it's still a disaster. So when we do handoffs, as you can see here, details get lost, right? So what we want to do, is stop the handoffs and stop the details getting lost, because then assumptions get made. So there's a quote from Alberto Brandolini, which says it's the developer's assumptions which get shipped to production, which is true, right? If I code what I think I heard, not what I should have heard, and therefore that's what makes its way into production. And so there's another quote from Eric here. Those who wrote the code, if they don't feel responsible for the model, and that's the code and the language you use and everything, then the model has nothing to do with the software. So everyone, architects, BAs, QAs, developers, domain experts, UX, everybody has a part to play in this, and everyone needs to play the role. So therefore, everyone who contributes to the model, and that means the ubiquitous language and all the other pieces, needs to spend time contributing to the code, maybe through pairing if they don't write code, but sitting close. And that's why hands-on is also at the heart of domain-driven design. If you're not using something concrete to try and express this language to a computer, then you're going to miss things. That's our second piece. We're on time. Any questions? No questions. Right, good. So then the third part, we're going to layer some stuff on top. So the first part, like I said, is a whole chapter, ubiquitous language. The second one is a pattern. The third one is buried. If you look for the words, it's buried a third of the way into the blue book. So why do I think this is the third part? Well, let's explain. For number one, multiple models comes from ubiquitous language. I've already mentioned it a little bit if you were listening carefully. And the reason that we have multiple models is because ubiquitous language is there, right? So, and the first mention it gets actually is kind of oblique, but it's in the ubiquitous chapter. And it's where at the end of the chapter, Eric says, at the moment, we've only talked about one ubiquitous language because we've only been talking about a single mental model. And so that's what he's talking about. There's a mapping between a mental model and a ubiquitous language. So what multiple models means is that there must be multiple ubiquitous languages. So when you discover another language, when someone talks about something in a different way, or it feels like they're describing maybe what you think is the same thing, but it feels like they're describing it differently, you've got a different language, right? So you've got a different mental model. And that's where bounded context comes in, which you could say is the third part, but I don't think it is. Bounded context is just the lines around your model to say this model is different from that model. The bounded word means it's, it's distinct. These things are different. Without multiple models, bounded context doesn't do anything, right? You don't have anything to put a boundary around. So multiple models existing in all but the simplest project is maybe not hard for people to understand. Because in lots of cases, we're aware of them, right? When things are working working well. So if there's a data format in another system, that's probably feels like another model, right? So we need to do data conversion. So we see this all the time in software and we understand it. But that's the technical dimension of the problem. Other instances of this problem are harder to spot, right? And so as Eric says, when the discrepancy is not with an external system, but within the same code base, it is less likely to be recognized. And remember earlier when we said domain experts frequently aren't aware of the specifics of the model? Sometimes without knowing it, they will have more than one mental model, but they won't have separated things because they don't think like engineers probably. They think about people trying to do some banking. That can get confused because they think they're describing the same thing and they're actually describing two things. And we'll probably all recognize this, right? We're having a conversation with someone and they're trying to describe things and they're maybe flipping between two mental models while they're trying to describe things, and then that's what you end up thinking. And it's because, like I said, they've got two models, but they don't realize it. And so if we're not aware that there could be two mental models, we're not ready to be able to say, oh, maybe there's two things going on there. Let's pull these things apart. So the way to solve this is be prepared for this happening. If you keep every model you draw clean and the key point is focused on a single problem and distinct from all of the other models, you'll know when your domain expert starts talking about something which doesn't fit with the model you have, they're talking about another model. And when another model gets talked about, then you can split things off. And to do this, you need to be proud of your models. You need to protect them and nurture them so you know what you're doing with them. And you can let ubiquitous language be your guide. So if someone's describing something, find out why they're describing it. What are you doing? What problem are you solving at this point? Because if you enforce a single ubiquitous language, and this is a failure pattern that you see, people think, and it comes from the naming because ubiquitous isn't a great name. Ironic for a thing about language, but ubiquitous people think means one to rule them all, right? One language to rule them all. It means one language for each problem. So if you have multiple problems and we build big systems, so we're probably solving multiple problems, we're going to have multiple languages, and therefore we'll have multiple models. So that's part one, 1232 Central European time. That's the black book, kind of black and white by the book pieces. What we can talk about in the next step is the lessons I've learned and the complexities and difficulties. But again, if anybody's got any questions before we go into the...
Actually, I have a question.
Yeah,
the other questions I gave you was from Uzi and Eric, but this is a question from me about the multiple models. Yeah. They are truly separate, right? But so the core business part of them might be a little bit different, but there are so many other things that are the same, that are common. Mm-hmm. How do you handle them in terms of...
So the short answer is by duplication. And duplication, but also, and again, I haven't pulled this out into the talk, but it's in the book. We tend to over model because we like modeling. So then we put things in model A. Well, number one, we don't realize we got two models. So we put things in model A, which should really be in model B. But also having duplication is fine because then DDD, again, in other patterns, which I'm not going to talk about, but it gives you ways to keep things in sync. And that's why events became a big thing or whatever. but what you want is just enough of the mental model to solve this problem, and then over here in other mental model and another bounded context, you need just enough of the thing to solve that problem. But duplication is fine. So that one of the things I'm going to talk about is dry, because people say, but if I'm going to do duplication, then I can't be dry. So it turns out that dry doesn't always mean what we think it means. So keeping a small focused model is important, and then you will have as little overlap as possible, but you might have overlap, and that's fine. That's DDD. Some enterprise architects hate that. So I've got a slide about that too. But
that's good. We have one more question from Helena Åberg, Astlund, and that was, can you give us an example of multiple models?
So a really, really, really good one is the Scottish criminal justice system, actually, and the English criminal justice system have the concept of a so England has what's called a pre-charge decision case, which is owned by the police, and it's before the police have charged someone with a crime, but they're trying to assemble. They have someone who is called a suspect, right? So especially this is good for like Nordic noir, right? So you've got a suspect, and they're the person who's probably done the crime. So you've probably got the ideas of the crimes, you've got pieces of evidence, you've got witnesses and all these things, but that hasn't been charged by the police formally. So therefore, it's not a criminal case, and it's called a pre-charge decision case. Then when they present that evidence and they go, right, we are charging you with a crime, and in Britain, and I think in North America, I guess maybe in Sweden as well, they have to formally charge you with a crime. The same person becomes a defendant, not a suspect, but they're the same person. The crimes stop being charges and they start being offenses, but they're still the same thing, like robbing a bank or something, right? And lots of the other information, like the investigating authority, et cetera, et cetera. So before I did DDD, I thought that was the same thing at just different phases or different statuses of the case. Those are actually different models, because one is supporting investigating and preparing a case. The next one is the shape of a case to take it through a criminal prosecution. And those are different because they solve different problems. One is prosecute a case, one is prepare a case for charging them with a crime. And they have massive overlaps, but keeping them separate. Or, for example, the definition of a product, and then like a bank account product, right? And the opening of a bank account. So you'll still have bank account, interest rates, and all of these things, but they're doing different work. One is creating the specification for a product, the rules for a product, and the other one is being a product that I can open a bank account, I can open and deposit money and take money out, etc. So hopefully that's clear.
Good answer.
But yeah, the big thing is if you think about what problem you're solving, they're like, oh, I'm doing this. Right, good. So that's different. Don't talk about that, talk about this, and then it works. So let's go fast. So I've got some words which I'm going to do it, but we'll go back through each one in time. So we'll do ubiquitous language first. So I built this so you can take a screenshot of it as well.
Sorry.
Yes, you can.
Had one of them and show them, can I have
yes, you can. Sorry, that's my son asking if he can have a snack. So number one, biggest ubiquitous language misinterpretation is, this is the thing, like we're all on lockdown, right? People say to me over and over again, do I really have to put these words into my code? Because I can just change it to insert. They have ubiquitous language everywhere until they go insert something, a row in a table. And I'm like, no, you should. If you lose it, you're translating and you're losing stuff. So we actually already talked about this, but that's the big one. You see people doing ubiquitous language all the way down to their code, and then they stop just when they get to their code. So don't lose information. Number two, people go, do we really need domain experts? Because it can't be that complicated. I might be biased because consultants don't get brought in for really boring, simple projects, but even the simple stuff is never as simple as I think. There are reasons why. And so the richness of people's domain models, even in simple areas, will really, really astound you. So you do need a domain expert, and that domain expert is someone with those rich mental models, because you need to be able to interrogate them, pair with them, work with them, and get access to those things, because they've wrestled with this business problem in real life. And it's the differences and the subtleties and the edge cases and all of those things you need to get to, not the boring, obvious bits. It's when is a Finnish bank account different from a Norwegian bank account, et cetera, et cetera. That's the things you want, right? And that's in the language, right? They'll have built this mental model up over years and years and years. That's what you want to get at. One thing that people then ask is, where do I find domain experts? So I've got loads of notes here because normally I can take longer rambling on about this. if I'll send out the thing afterwards, finding domain experts is not in the book. One of the gaps in the blue book is you just get domain experts and they've magically appeared. Finding domain experts is a bit of a complicated thing to do. There is an archetype which I've kind of written down because I've been lucky enough to work with some awesome domain experts. And what you can do is there's a list, and you can see it on the slide notes. But it's kind of how the key character traits that you want to look for in someone that you can get to work with you. Key fundamental one is that they're not frustrated working with developers, because working with us can sometimes be quite frustrating. And then the last point, if you're really lucky to get lots of experts, and I have once, twice, 3 times actually, what happens when they disagree? That's cool. You just give them the pen or give them the access to the Mural or Miro board and let them do the discussion, right? Because you will learn so much about the domain by hearing them debate whether or not this type of criminal case in Scotland. So our example was Dundee and Aberdeen were applying the Scottish law differently. We thought we had to solve that problem. We let the chief public prosecutors for Aberdeen and Dundee fight it out, and then they discovered that that Scottish law could accommodate both options, and then we learned that was the detail, right? That's what we needed to find. But if we decided that, if we quelled that debate, then we wouldn't have lost it. We would have, we would have lost the detail. So that's ubiquitous language. What about hands-on modelers? Another thing that's in the book, it's very XP. It doesn't talk about BAs. It doesn't talk about UX. It doesn't talk about testers. And you could read hands-on modelers chapter and think those are all redundant. Again, I think if we were as good at adopting all of these different modes of thinking, which we get from colleagues who are UX, BAs, testers, etc., then we wouldn't, those job roles would have disappeared. The reason they still exist is because we as developers aren't good at swapping all of these different modes. So what we need to do is work with them and pair with them, because the thinking tools that they have, the tools that BAs have, that UX have, that testers have, for taking what we call a domain and they call different things, but fundamentally it's the same thing, getting at the mental models and using that to build better quality, more focused software is key. And so what we can do is we can pair with them. We can model out loud, and there's a chapter called that, a pattern called modeling out loud. That's what you need to do, is to figure out how we can work well with them to get access to their skills and use them to bolster our skills as developers. Another cool thing. So again, it's not, although despite being, he knows Kent Beck, but Eric Evans doesn't say anything about TDD. DDD loves TDD. So to Matthias's question, where do you kind of, it's not really Matthias's question, but how do I push this language safely and confidently into my domain code? The way that you can do it is write your tests initially incompletely. If you write your tests so a domain expert could read them, that will keep them small, because a domain expert doesn't want to read 17 lines of data setup, right? So you'll keep your test nice and clean and focused. But if they read a set of facts and statements about your domain expert will, I've done this, you pair with them and they'll tell you what you've misunderstood. And that's good as well, because we'll talk about it in a minute. If you've got a nice suite of tests, you've got a safety harness for your understanding of the domain. A little bit, can you do functional code, functional style DDD? Yes, you totally can. If you read the chapter, which is called the supple model, that is basically Eric advocating for writing OO in a functional style years before Kotlin and Scala came along. So you totally can. But the anti-pattern is you can't use procedural and data-centric models. So if you see someone who says they've got a domain model or a DDD domain model and it's written in an ER diagram style, you're going to fail, because that focuses on the data and completely ignores the behavior. So if you're ignoring the behavior, you're missing 85% of all of the richness in the domain. It's not about the nouns, remember, it's about all of the other pieces. So that's those 2 bits flushed out. So we're now race to the finish and then let everybody have time for questions. Let's take a step back. So remember I said earlier, the relationship with ubiquitous language wasn't passive. We need to cultivate it. So we've talked a lot so far about this direction going from ubiquitous language to modeling. Now let's step back and reconsider the second dimension. And we got to remember, design's an initiative process, right? So we're building this language, we need to use the language and we need to kind of loop around on it, right? And so therefore, when it's wrong, we need to correct it or make it deeper or richer. And Eric says it's important to be hands-on so we can embed the ownership. So that's important, but there's one other thing that's important. And I just mentioned it a little bit with tests. If we're taking this language and we're writing it in our domain code, but also if we're writing it in our tests, we can build up our understanding and then we can run our tests and it all works. And then we build, add a little bit more domain understanding to some tests and we run our tests and then some of them fail. By getting hands-on, we can understand when from a code, a code feedback loop, a TDD feedback loop, that some parts of our understanding of the domain are incompatible with each other, right? Because each individual test makes sense, but then together they don't all work. And therefore, that leads us on to the next big topic in DDD, which will take us to the third aspect, which is called breakthroughs. So breakthroughs are also known, I think this is a quote, I've got it in quote marks, when your model makes a sudden and significant leap forward in depth and focus. And the problem is that breakthroughs aren't techniques, they're events. So how can we focus on reaching them efficiently? The way I now do it is based on the fact I've been brainwashed by ThoughtWorks. I do TDD because I want to write a test which will break my model. I don't want to write a test which will validate the fact that this extra piece of domain information is correct. I want to write the test which will still be correct, but will maybe invalidate the model I've already built. And then we can build our learning, right? Just like you do with TDD, just like Kent Beck talks about. And what we do is when we get to the point when something breaks, we get to a breakthrough, but there's two types of breakthrough. One type of breakthrough means we just need to do a significant refactoring because it turns out that how we'd implemented our codes to meet our tests was wrong. But then sometimes there's another type of breakthrough, and that's the ones which gets us to our third part. So let's back up a little bit because this is the super important bit, and this is how we get lots out of DDD. It's how we get to microservices. It's how we get to stream-align teams, accelerate team topologies, all of the stuff people talk about. So we said before that we clarified ubiquitous. Ubiquitous doesn't mean one language to rule them all. It means one language and a model to span the technology and mental divide to solve a single problem. So sometimes when we write some tests and our model breaks, we realize that we've actually discovered a separate model. So we need to split things in half. So this is going to just like Helena's question, right? We've realized that one model that we had can't do everything. So we need to have acknowledged that we've got another mental model. And just to make sure, that you don't end up with too many attributes. If you've got a set of tests which are, trying to put your code under pressure that they can't do, you can refactor driven by those tests and you can pull the right attributes over to the separate model without bringing too many pieces over. So your models stay clean and focused and they meet your requirements. And then when you've got that, you've got your multiple models, you can then kind of loop back around again, right? Now you've given yourself freedom because you're realizing that you're solving two problems and you've got two models. And that's how microservices right? So, and that's why, in my opinion, multiple models is the real power of DDD. Because if you've come at it from the right angle, and the right angle, if you haven't been paying attention, is ubiquitous language and hands-on modeling, then you won't get the right splits. Anyone can split their code, but I think I've done it. If you split your code in the wrong place, you just get like a distributed monolith, which ThoughtWorks love to talk about. And, one change for one feature from a business person means you have to touch 17 different microservices, et cetera, right? So we've all felt the pain of this. If we split down business lines and mental model lines, then things get a lot simpler. So multiple models, number one, unlocks bounded context. So bounded context is like the most overused term in software delivery these days, but they are powerful, but people just think it's like a bit of software. But it's not. It's a bit of software that represents a single ubiquitous language that does one thing. Yep, I was going to rant a bit more, but I'm going to stop. So then we get to what about dry? So again, in the show notes, there's a really good post by Matthias Freitas, and where he points out that the dry thing that we talk about, which comes from Dave Thomas and Andy Hunt in The Pragmatic Programmer, we sometimes forget it and we misinterpret it, right? So we're brought up as developers to think, we shouldn't duplicate things. What we should do is keep everything, have one piece of code in one place. But what we should do is have one piece of knowledge in one place. And if something represents this different pieces of knowledge, even if it's the same at the point we implement it, that should be two pieces of code. Because if it's one piece of knowledge, I want to change one piece of code, right? Because I learned something and I changed that piece of code. But if it's two pieces of knowledge, which might just sound like the same thing, for example, I think in Matthias's example it's a basket limit or an order limit, the number of items in an order. that manifests in the basket context as the number of things I can put in a basket. But in the shipping context, the maximum number of items in an order is different because it's serving a different purpose, right? So those are different. We shouldn't have that specified in one place. We should have it specified in 2 places. So whenever you hit the dry question, are you repeating knowledge or are you repeating not knowledge? Can't remember what the opposite of knowledge is. Another 2 quick ones, then we can finish for questions. Canonical data models is a way to go. This is the one place where the concept of user lives and nowhere else. That will fail because the concept of user will appear in lots of different places, right? Maybe it's owned and mastered in one place, and maybe that's the user profile management, aspect of your domain. But user will pop up all over the place, right? So duplicate just enough of the concept of user and keep it in sync with events or something, but don't say, every time I need to know a user's first name and address, I need to call somewhere else to get it. If I'm in the order context, hopefully I've already kept a copy of that data. And final thing, this is an ex-ThoughtWorker who put this in a book, but I think that's where it came from, but people ask me about it all the time. Nested bounded contexts don't exist. If you have what you think is one bounded context, and then you prove that it's 2, you don't have a nested bounded context inside another bounded context. You've just given yourself 2 bounded contexts. So things can't live inside bounded contexts. They're kind of separate. And I think that's it. I'm now going to find out if I've gone too long or too fast.
This is like exactly 50 minutes. You are so good at this.
Yeah, I'm good at this. The first time I did this, it was not that good.
So we have about 5 more minutes before we let people go to their meetings, and then we can continue with more questions. So we can open up for questions, and you don't need to type them. You can unmute yourself if you have any questions.